Metal transfer is the term used to describe how metal leaves the filler wire and enters the weld pool, and the way in which this occurs has an important effect on the weld. There are essentially three basic ways, or modes, in which metal transfer occurs, namely short-circuit mode, also known as short arc transfer and dip transfer, globular transfer, and spray transfer. Short-circuit transfer is desirable for the welding of thin metals up to 2 mm in thickness. It is also used for many out-of-position welds and for the filling of holes. With short-circuit transfer, the process begins as an arc is struck between the end of the electrode wire and the base metal. The arc heats the base metal to form a small weld pool. The wire, being fed into the weld zone, touches the weld pool, and a short circuit occurs the moment metal enters the weld. The welding machine, in attempting to stabilize the output voltage, causes the current to rise dramatically. This current increase results in a pinch force that causes the tip of the electrode wire to separate. Having separated, the arc reignites as a result of the welding voltage returning to its set value, and the cycle is repeated. The wire is fed continuously into the weld zone, and a cycle of arc on and arc off is set up at a frequency of between 80 and 200 times per second, which to the human eye appears as a continuous arc. Let us now consider spray transfer. Spray transfer requires relatively high welding voltage and current. The high voltage results in a continuous arc between the electrode tip and the base metal. The electrode wire does not short-circuit onto the base metal, but melts in the form of droplets within the arc. These droplets are attracted by electromagnetic forces to the base metal. It should be noted that spray transfer will only occur in the presence of an argon-rich shielding gas. Spray transfer is a hot weld, resulting in deep penetration, and for this reason it is used to weld thick material, but is limited in most cases to downhand position work. The result of spray transfer is a very fluid weld pool that freezes into a smooth bead. Lying in between short-circuit transfer and spray transfer is a mode called globular transfer. Globular transfer can be described as the transitional phase between short-circuit and spray modes. Globular transfer is, in essence, the result of the welding voltage being set too high for dip transfer, but too low for spray transfer. The metal droplets that melt off the electrode wire are larger than the wire diameter, and they transfer randomly towards the base metal, often resulting in an uneven bead and excessive spatter. The modes of transfer so far mentioned, namely dip, globular, and spray, can be achieved using most conventional constant voltage MIG/MAG welding machines. The four main factors affecting the type of metal transfer are welding voltage, electrode wire size, type of shielding gas, and the wire feed speed. During Program 3, you will learn how to set your equipment to achieve short-circuit and spray transfer modes. There is a fourth mode of metal transfer known as pulsed spray. This mode, however, requires a special welding machine known as a pulsed unit. Pulsed spray is essentially a more controlled version of spray transfer. Molten metal droplets from the electrode wire transfer across the arc in a constant and regular stream as the power source sends current pulses to the tip. This is achieved through sophisticated electronics and circuits built into the machine. The pulsed process produces a cooler weld than conventional spray, and is therefore suitable for the welding of thin metal and out-of-position operations.